First of all, I want to make sure I need a mic. Yes? Because of the sound structure, yeah. Okay, so first, some apologies for some part of the audience. I'm mainly interested in those people. Because the future of science is you. The future of science is your generation. Okay, that's hard. I want to move. Vocation. You may worry about vocation. Do I have vocation? In fact, I'm uneasy with the word vocation. I'm uneasy because of its religious undertones, because it has been used, misused, abused by politicians that are using it to essentially restrict the political life, la véritable vocation de la France. And in the end, even if you take the Latin etymology, the calling, who is calling, what is calling, I have no clue. And in fact, when I was your age, no one was calling me. I was interested in sciences, and I hope you are interested in sciences. I had no clue what research was in general, in mathematics, which is my field in particular, although I was born in mathematics since my father was a mathematician, a great mathematician. And I still had no clue. I mean, I could see him working very hard in his office all the time, but I had no clue what it really meant. So I was interested in sciences, and let's face it, let's be honest. When I was your age, I was attracted to sciences. I was interested, I liked it. The classes were relatively easy, but I was even more interested in sports, music, and girls. So in the end, vocation, at least for me, no. I was interested in sciences. In fact, at 16, I wanted to be an engineer. Later on, I had no clue when I decided to go into sciences and willing to try to do research, to give it a try. I still had no clue. In fact, I had absolutely no clue that I would do research in maths. In fact, my original plan was to do something at the interface between computer science and probability theory. But as usual, things do not go according to plans. So a lot of random events, good teachers, accidents, meeting interesting people, and so on. And I gave it a try. I'm using I, and I feel a little bit reluctant to mention personal experiments, but I certainly want to avoid generalities, because if you take a notion like vocation, there are dozens of books which have been written on how and why does one choose a particular professional life. So let me avoid complete generality, and sorry to make a few personal comments, which are of course of a very limited interest. So I decided to give it a try without really knowing what it was, and I was hooked immediately. I fell for maths, as they say, hook, like, and sinker. That's what I felt about research in applied maths when I started, and 41 years later, I still have exactly the same feelings. In fact, on a slightly more lighter tone, I would like to seize this opportunity to thank the taxpayer. You know, I feel a little bit like Droopy in those Tex Avery cartoons, hello, happy taxpayers, because indeed, I think I've been extremely lucky to be given a decent, well, semi-decent salary, to have lots of fun. And indeed, I had tons of fun, and I'm still having fun with research in maths. So the conclusion, you see, I'm going to be very, very brief. The conclusion is that if you are interested in sciences, try to do research. There is no way it's a win-win situation. Even if you don't like it, and if you don't get hooked, and if you don't become an addict like I am, It's fine, because this is an excellent training. And our modern countries really do need training by research, and not only training for research. So, and if you like it, I can promise one thing, that it's going to be lots of fun, and you may have a very, very interesting life. Time to thank you for your patience, and soon more serious speeches than mine.
Merci Pierre-Louis. Maintenant, je passe la parole à Claude COHEN-TANNOUDJI, prix Nobel de physique en 1997. Tu te mets là-haut? Oui, oui, bien sûr.
Dear colleagues and friends, dear students who are here today, we are supposed to speak about our scientific vocation. In my case, scientific vocation came from the contacts that I had chance to establish with many people that I met during my life. First of all, my parents. Their condition was very modest. They didn't have the chance to follow advanced courses. But their main concern, the most important thing for them, was the education of their children. I learned, this is how they gave me the passion for learning, for thoroughly understanding the subject that I was studying at school. At the beginning, they were hoping that I would become a medical doctor, as most family at that time. But at the end of high school, when I was preparing exams for entering the École Normale Supérieure, which is a grande école in France, I had a mathematics professor who was very interesting, and I decided to learn more about it. But when I was admitted at École Normale Supérieure in 1953, I met there a really outstanding professor of physics, Alfred Kastler, who made me change my mind, and I decided to switch from mathematics to physics. Alfred Kastler was describing his experiment on atoms and light with such a clarity, with such poetic image. In fact, Alfred Kastler was also a poet. He was so kind with his students that I decided to join his research group that he was leading with Jean Brossel, another outstanding physicist. This is how I discovered the fascinating quantum world of atoms and photons that I didn't suspect before. To follow very interesting courses given at Saclay by Albert Messier, a very famous name, Anatole Abraham, and also at Les Ulles Summer School, lectures given by the most advanced physicists of that time, like Wolfgang Pauli, Julian Schwinger, Norman Ramsey, Charlie Towns, who was the inventor of the laser. You know, and also, this is how I became a researcher, excited by the desire to understand the phenomena that he was observing, but by the opening mind to new fields, new topics. And I was, in that way, also very interested to try to attract in my research group very brilliant young students like you, and like one of them who is here today, and will become also a Nobel Prize winner, Serge HAROCHE. And also what I would like to say is that during my scientific life, I was also passionate by teaching, because I think that teaching is a very important part of research. I had the opportunity to write several books, in particular a 3-volume book on quantum mechanics with 2 colleagues, Bernard Dieu and Franck Laloé, who is now used all over the world. Also, I was so happy to establish contacts with scientists all over the world, and in particular, scientists from Israel that I visited several times, and always happy to meet them as today in this institution. This shows that science is a very international activity. Finally, I would like to say that I've always been supported by my family, by my wife, Jacqueline, who has been a high school teacher in physics before retiring, by my son, Alain, my daughter, Joël, who are both doing research in biology. This is very important. You see, I would like to stop now. I hope to have convinced you that science is a fantastic adventure. And I hope that some of you will decide to live such an adventure. Thank you very much for your attention.
Merci, Claude. So now the floor is to Aaron Sissenauer. Okay. Nobel Prize of Chemistry in 2004.
Thank you very much. Almost everything was said. So the only thing that I can add is, Neely, maybe you can ask Catherine that the French Academy will give us as a loan this building for 1 day in a year to have our Academy meeting there in Jerusalem, and then we promise to give it back. It's really gorgeous to be here. And just a very short statement or say to the young generation, from my own, everybody has his own experience, but people from time to time, especially young people, ask me when I tell them about science and more about science and more about science, they ask me, and what is your hobby? I said, my hobby is science. That's what I'm doing day and night for 40 years, and every day that I come to my lab is like the very first day, and they wonder why I don't collect stamps, why I don't play a violin. And I say, no, science is vast enough and immense enough. And I think that if you think about it, if you do something that you really love and you really have passion to, it will hold you for a very long time. And then I have a president of my university who is present here that every month even put a check in my bank for me playing with my hobby. So if you are able to assemble all these components doing something that you really love, then you don't need to look for a hobby. Then you can contribute to society like I hope we did. No, not directly, but there are millions of people these days who are enjoying the drugs that were developed based on our discovery. And then the university even can pay for you. But I think that really passion will make you good at what you are doing. And I wish you all a very enjoyable and fruitful conference today. Thank you very much.
Alors, nous sommes une académie des sciences et peut-être nous n'avons pas d'économistes dans notre académie, mais comme nous sommes une académie extrêmement ouverte, nous acceptons tout le monde. Et je suis très heureuse que le prix Nobel d'économie, le prix Nobel d'économie, pardon, Robert Aumann, okay, who get the Nobel Prize in 2005, I think, give a talk.
How do we turn on the...
just switch of this.
Do it? Okay.
Just give me a second.
Okay, I don't know anything about scientific vocation. I know a little bit about science, so I'm going to talk about science. Please excuse me. Yes. Where do we have the slides? Good, okay. So here we go. So we're going to talk about agreeing to disagree. And let's start first. A salute to the outstanding French School of Mathematical Game Theory, created and led by Professor Emeritus Sylvain Saurin of Paris 6 and the École Polytechnique. It is magnificent, it is excelled by none, and it's right here in Paris. So this is really a celebration of scientific collaboration between Israel and France. And a vote of thanks to the French and Israeli Academies of Science for arranging this lovely celebration of the 70th anniversary of Israel's independence. As we heard, there was scientific collaboration between France and Israel long before Israel became independent, but it's nice to get this celebration of the 70th anniversary. Okay, science. Terminology. I'm going to distinguish between facts and opinions. A fact is an assertion that something was, is, or will be. For example, in 2025, most cars in Paris will be driverless. That is either true or false. It's a fact. You want to distinguish between facts and opinions. An opinion is an assertion that something should be. For example, developing driverless cars should be encouraged. That's an opinion. It's not a matter of truth or falsity. The first one is a matter of truth or falseness. Now, a very fundamental concept, which was first defined by the philosopher Lewis, C.D. Lewis, David Lewis, common knowledge. And we say that two people commonly know a fact if both know it, both know that both know it, both know that, and so on. So when we're having a telephone conversation, then it's common knowledge between us that we're having that telephone conversation. Common knowledge sort of creates, out of two or more people, it creates them, makes them into one unit as far as their knowledge is concerned, okay? There's no doubt about whether, there's no mutual doubt about the object that is the common, that is the object of the common knowledge. Now we say two people, Anne and Bob, agreed to disagree on a fact if they commonly know that they ascribe to it different probabilities. Okay? If they commonly know that Anne prescribes to it probability 2/3, and Bob ascribes to it probability 1/4. This is common knowledge between them. Now, of course, 2/3 and 1/4 are not important. It could be 5/8 and 4/17 or whatever you want. I just use this as an example. I wanted to give this talk without any mathematical symbols, okay? So, excuse me? Probabilities always have to be, it could even be one, yes? It could be one. It can't be more than one, because probabilities can't be more than one. But it could be 1 and 0. It does not have to be less than 1. Two numbers between 0 and 1. And now there's a theorem which I published in 1976. Two people cannot agree to disagree on a fact, even when their information is entirely different. You can have entirely different information, but they cannot agree to disagree on a fact. It can't be known to them as a unit that one ascribes to it probability 2/3 and the other one 5/8. Of course, they can agree to disagree on matters of opinion. For example, they can have common knowledge of differing opinions. One could say that driverless cars should be encouraged, and one could say that driverless cars should not be encouraged, and they can have common knowledge of that, but not on facts. So if the probabilities are different, at least one of the two must be making errors in reasoning, or must ascribe such errors to the other, or mutual knowledge, Anne knows that Bob knows that Anne knows that Bob knows, must fail at some level. Okay? This is not really natural science, it's mathematics, okay? It is a mathematical truth. Of course, one has to give the proper interpretations to the verbiage over here, but it is something that can be proved, and it was found to be a little surprising in any case. Merci. Toda.
Merci pour cette démonstration. Maintenant, c'est Albert FERT, prix Nobel de physique en 2007.
Good morning, bonjour. So, vocation for science. For me, not very early, only gradually. As I will explain to the young people, my vocation came only when, during my thesis, my PhD, I realized that even for a beginner in research, there was a lot of space in physics for the exploration of new tracks, for surprising discovery, and some space for the imagination of the researcher. What is important is, what is a real pleasure is to play with his imagination. So I will explain more precisely how my vocation increased progressively from the teenage years to my PhD. So at the time of the secondary school, yes, the teenager took a real pleasure in elegant solutions of mathematical problems, or in understanding deeply and precisely some complex physical effects. And I like also to speak about the recent advance in science with my father, who was a physicist. But I, as any teenager, as you are, I was also discovering many other pleasure and passions. Literature, at this time, we had in my lycée in Toulouse, very brilliant teacher in Greek, Latin, and French literature. And it was supposed to be something above the science. What I discover also is the arts, music, for me the jazz music, sport, for me was the rugby. And so my vocation for science was not very clear. So many attractive directions. You also should also see that there are so many directions to follow for you. At 17, after my success at the baccalaureate, I had to choose the directions. The parental pressure was for science and mainly for what we call in France the grandes écoles, and especially École Normale Supérieure in Paris. For me, École Normale Supérieure was also attractive, not only because due to the high level of the scientific education at École Normale Supérieure, but also it was in Paris. I want to leave Paris, Toulouse, my town in the south of France, to Paris, the Latin Quarter, Saint-Germain-des-Prés. L'École Normale Supérieure was Rue d'Ulm, just close to the French Cinémathèque. I like very much cinema. And also around there was all the theater, concert halls, jazz clubs, art galleries. So I was motivated. I worked a lot to pass the examination, and I could go to the École Normale Supérieure Rue d'Ulm in Paris. At the École Normale Supérieure, I chose physics because I was impressed by the lecture in quantum physics of condensate matter by Jacques Friedel. Claude says that he was impressed by the lecture, by the influence of Kastler. For me, it was Friedel, another great scientist. And so I chose physics, but at the time of the PhD, my question was, in this beautiful landscape of science, with a lot of things created by great scientists, what more can be introduced, can be added by a young researcher as I was? Expressed differently, the question was, is it possible to be creative in physics as an artist can be creative in its art? So this was my question, and my work in research during my PhD showed that the space in physics is richer in surprise and discoveries. I found that the small results of a young researcher I was could bring some new light of an important problems. It was a surprise, and open also the tracks for other discovery. Actually, I could be more concrete. My thesis could demonstrate that in a magnetic metal, the electrical conductions can be very different for the electron with opposite spin direction with respect to the magnetizations. And it was a very small results, but my meeting with other results, by meeting with discussion with other physicists, I remember this time not only Jacques Friedel, Ian Campbell, Peter Levy in New York, it led to other advance, and finally it was the first step of what is called now spintronics, the field of spintronics. So during my PhD I became really motivated, not only motivated, I would say addict of physics, addict of research, an addiction that probably I share with most of my colleagues, researchers, our common addiction to go all the way forward and to explore beyond the horizon of what is known. I suppose you share this feeling, both all of you. The next step for me was the discovery of the so-called giant magnetoresistance, also discovered by my Nobel laureate Peter Grunberg, and then the development of a new type of electronic called spintronic. The cherry on the cake was the Nobel Prize. And of course, the Nobel Prize slowed down my research during 2 or 3 years to take on other activity and responsibility. However, just after, I could come back energetically to what I like, that it is physics on new roads, today's Kirchhoff's topological matter. And to the students, I can also say that the research brings all the other satisfactions, not only the exploration and the discoveries. Another pleasure, working with a team, working in a team. What I like is to be in my lab and meeting with my co-worker, discussing with my co-worker and with other colleagues. Another interest, our job, is the international connections. All the people we know around the world, all the friends I have around the world. I have a good memory, for example, my postdoc in UK, interesting not only for my scientific career, but also for my career of rugby player. The British rugby was interesting for me. And also very good memory of all my stay at New York University, not only for the animated discussion I had in the office of my friend Peter Levy, but also for all the evenings in the bars and jazz clubs of Greenwich Village. So I hope that what I have said on the interest of the life of a scientist, of a researcher, can help some students to get an earlier vocation than mine. And all your questions are welcome. I thank you for your attention.
Merci Albert. Il n'y a pas beaucoup de femmes qui ont reçu le prix Nobel, mais aujourd'hui nous en aurons 2. Et c'est avec un très grand plaisir que je passe la parole à Françoise BARRE-SINOUSSI.
Merci Catherine. Comme vous avez entendu par beaucoup, vocation, c'est moi aussi un mot que j'aime pas. Je préfère passion, je préfère amour de la science. Alors comment les choses ont démarré pour moi? Autant que je me souvienne, je ne savais pas trop lorsque j'étais jeune ce que je voulais faire, comme beaucoup. Simplement, c'est vrai que durant mes vacances à la campagne, j'adorais passer des heures à observer la nature, to make observation of animals, to make observation in the nature, to see differences between animals. And at school, and particularly high school, it was very easy for me to be successful in my exam in science, particularly life science. So after the high school, I said to myself, there is 2 options. Either I go to medical school, and I was very interested by medical school, or I go to science university. I decided science university for a wrong reason, really. A wrong reason because I was coming from a modest family, and I thought that it will be less expensive for my parents to make study at the science universities, and in high school it would be shorter. That was wrong. When I was at the university after 2 years, I was starting to ask to myself, am I in the right direction? Yes or no? I'm not so sure. I still do not understand in the university what it is to become a scientist, to become a researcher. So at that time, I decided something unusual, to try to find a lab which will kindly accept me in the lab for free and part-time in order to continue to study at university. And I was lucky enough to find one at Pasteur, at the Institut Pasteur. And this lab was working on interaction between retroviruses and the host. And suddenly it was clear to me, yes, I wanted to become a researcher in life science. That was so clear that I'm not a good example, to tell you the truth. I started to stay mostly in the lab, not going very often at the university, except, of course, to get the exam. And it's how everything started. And the next step for me was, like most of the scientists, to go to the US to make a postdoc until a very important step that changed my life. An emerging disease, and people were dying. I had the opportunity to work on that disease, but not only to work on that disease, to meet clinicians, to meet people affected by the disease. And then I remember really what Louis Pasteur has in mind when he was saying that science is there for the benefit of humanity. That is really was a critical step for me. I had the chance to go in many countries in the world, to meet a lot of people with different culture, different tradition, in terrible situation, and I learned how to try to adapt research to their expectation. That is the wonderful adventure of science, to try to bring scientific knowledge for the benefit of humanity, to try to have a better life for everyone. That's all I wanted to say.
Merci Françoise, merci beaucoup. The next is again a woman, Ada YONATH, who got the Nobel Prize in Chemistry.
Good morning, and thanks for coming here, especially you, the young people. Actually, people ask me what happened to my life after I got the prize. So I meet, like you just heard, a lot of people, interesting and less interesting, other cultures, other experiences, but what makes me really young people is being able to talk to people, young as you are, that show interest in science. So thank you for coming here. That at least science, maybe. So you see, I don't even know how to hold the microphone. Prize is not all. So the title of our speeches here are Vacation in Science. Actually, I feel vacation until now, although I'm more than 50 years working in science. Already you heard that science is like our hobby, and this is also correct, but I have also other hobbies. We can talk about it some other time. Most of the young people that I meet, as you are, ask me how to get the prize. How can I be a prize winner? That's not important. The real importance in my life was the discovery, the finding, the answer to the question that I was curious about. And what was I curious about? How the genetic code is being translated into the cellular workers. You know that each cell has workers. We have to do lots of things. Each cell, bacteria, cockroaches, lions, fruit, flowers, fish, all of them have cells, all of them are living, and the cells have to do things, tasks for being able to live. And this is done by the cell workers. They are called proteins. They can work only when the sequence of their components is correct, and this is given, the instructions for it are given by genes, by the genetic information. And it all was known when I was a young scientist, but not how. How can it happen? How the cell can translate the information quickly and correctly into the workers. So let me talk about quickly. It has to make bonds between the components. They are called amino acids, for those of you that know. I was a student. I had to make one bond like this when I was second year in the university. And I was the fastest in the class. I did the lab work the fastest because I was very, very poor and I had many jobs and I had to go to my jobs. And it took me 6 hours to make one bond. And in the cell, 40 are made in a second and correctly. So it was really, I was curious about it. In the cells, in all cells, ribosomes are doing it. They are cellular components, cellular particles, and I wanted to know how they work. This is all what I wanted to know, but I was really curious about it. And if you think that the scientific community thought that it's possible, well, there was lots of controversy and mainly negative, because many others tried and failed. So I knew maybe I will fail too. And then I joined very good people that failed. But anyway, I don't want to go into all the details. I only wanted to understand this process. And you know what I got as a bonus? I also know how almost half of the antibiotics that are being used clinically work, because they are stopping this process. This is the way that bacteria of one type is fighting against other bacteria by antibiotics. So first of all, I didn't even dream that I will understand how antibiotics work. Now we do, all of them. Not only this, we also know how resistance to antibiotics is being acquired, and because of it, we can try to come out with new ideas. You know that resistance is a huge global medical problem today, and recently, the last 2 years, we could come up with an idea to make completely new antibiotics, new generation that will be effective medically, but also effective in preserving other lives, the lives of the good bacteria that are inside us, and eco-friendly. So you see, this is just a prize that I got for what I was curious about. So before I finish, I want to say some words about science in general. I cannot say what is really more important now to learn, physics or mathematics or biology. I don't think that there is such rigid border between them. The borders are fading out. It's science. Look, the problem that I just told you about that interested me was biology, was medical. The method that I was using, crystallography, is physical. Since I was one of the pioneers of this method, we had to do also mathematics. And at the end, I got the prize in chemistry. So it's all together. But if we talk about chemistry, let me say some things about this. Throughout Nobel Prize history, there are only 4 women, 4 ladies, 4 people like me that got the prize. 2 of them here, actually in Paris, but in France, Marie Curie and Juliette Curie. The third one in Oxford, Dorothy Hodgkin. Let me say some words about Dorothy Hodgkin. Her first PhD student became the head of the department where I studied afterwards, after I got this prize. Dorothy Hodgkin determined the structure and the function of insulin, of penicillin, of cholesterol, and of vitamin B12. Together with her first student, that his name is Gerhard Schmidt, was a female student. She kicked her out because she wasn't good enough. You know the name of this female? Mike knows. Do you know? You sure know. Margaret Thatcher. So there is a hope even for students that started to learn and they're not so good. One more thing about French scientists that contributed a lot to crystallography, to the method we used. His name is Fourier, Joseph Fourier, that studied here in École Normale in Paris. So, as you can understand, I am now the only female chemistry laureate that is alive. Dorothy Hodgkin died almost 20 years ago. Girls, will you join me? I invite you. Thank you.
Thank you very much, Ada. So the next is Elon LINDENSTRAUSS, who got a Médaille, Fields medals in 2010.
I think I'll use that.
Okay. Use what you want.
So I didn't help fight the AIDS epidemic, and I even didn't find the mysteries of how living cells produce proteins and things like that. I'm a simple mathematician. When I finished my undergraduate studies, I sort of had a very hard time deciding between physics and mathematics. But you could see what I chose. So the truth is, you can't see, because I chose physics and then made the practical arrangements to start studying physics and then changed my mind. And it's a bit like Professor BARRE-SINOUSSI said, many times in life when you are facing an important decision, you sort of think about it very hard and you sort of make all sorts of complicated reasons for and against, and then you make a decision, and in retrospect, often the decision was based on, you see that the decision was based on, you didn't attach the right weight to each consideration, but at least for me, this worked out okay. Mathematics is an exciting area, and being a mathematician certainly has a lot of positive aspects to it. It somehow has the advantage that it is, surprisingly so, useful. I mean, like my colleagues said before me, it is to some extent, we're always surprised that people are willing to pay our salary for doing things like what we're doing. And mathematicians have the advantage that mathematics is actually useful. But it has also the advantage that it is useful in a very non-direct way. It's not, there's no immediate commercial pressures. You're not going to get out of whatever equations you're solving, no cancer drug would appear, nothing which would, it's not going to fund a $1 billion startup. It just would take time and somebody would eventually might find some use for it, but you're sort of free from this pressure. So for that respect, mathematics is a very nice field to work on. And there's also, I mean, many other nice features about being a mathematician. One of them is, maybe a big part of it is your interaction, collaboration with other mathematicians. So for me, ideal working day is basically sitting in a nice cafe with a colleague that I feel comfortable with and exchange ideas, trying to work on something together. I find, and probably most people do, that most of the time you're not using all of your brain to think of something, you're using only parts. And okay, it's sort of an individual thing, but for me to really work on something with all of my capacity, I need to enjoy it. It needs to be fun. Somehow, if it's not fun, I am not able to really engage and really do the best that I can. In this age, I mean, there's many, if you read the news, it doesn't make you feel any better about the world nowadays. But in these days, mathematics is actually thriving. It's a golden age for mathematics. There are many directions which were developed individually and sort of very deeply, and suddenly they find connections. You see a lot of progress now. And you could see that some of this great conjecture that were open for many years, the Fermat conjecture, the Poincaré conjecture, they were all solved not in the last couple of decades. When I meet young mathematicians, what I often want to learn is what their mathematical dreams are. A mathematician needs to have a dream, which would be exciting enough to compensate for all the frustrations. A mathematician's career, it's not like an experiment that you're sort of doing something all the time. A mathematician, 99% of the time, basically is failing. Only 1% of the time you're actually able to prove something to make an advance. And having a dream helps you pursue this, and also having a dream the dream should be clear enough that it helps you to compensate for all of the obfuscating details along the way. So there's many details, things, but the dream should be clear enough to show you the path. It also should be clear enough to allow you to judge when you do something. Is this really interesting? Should I really be excited? When you have your dreams, you have some kind of milestone by which to check how exciting what you're doing is or isn't. I see here many young women in the young part of the audience. One of the nice developments in mathematics is the increased prominence of female mathematicians. I can see a noticeable difference. I mean, I'm not, I think of myself as being a young person. I see a noticeable difference between the time I started studying mathematics and now. I think, and you could see somehow that many of the leaders in mathematics now are women. Yeah, so I think mathematics today is in very good shape. It has the advantage of being useful, together with not being directly useful. New mathematical ideas are really exciting, and there are really profound ideas that are coming out from the community. So I'm happy to be able to play a small part in this. Thank you.
Thank you, Elon. Le suivant devait être Cédric Villani. Alors, Cédric Villani a eu la médaille Fields en 2010, la même année, pour ses travaux sur l'équation de Boltzmann. Mais voilà, tout le monde connaît Cédric Villani. Vous l'avez tous vu à la télévision. Il a décidé de partir dans une carrière beaucoup plus politique, mais en fait, il a eu envie de faire le lien entre les scientifiques et la société, et nous espérons tous qu'il sera un de nos ambassadeurs. Aussi, je passe la parole à Serge HAROCHE, prix Nobel de physique en 2012.
So when I was first asked to speak in English to French students, I found it was a little bit strange. But then I understood that there was at least one rational reason for that. If you want to do science, you will have to speak and to communicate in English anyway. So that's, I think, the main reason for speaking in English today. The question about why are we doing science is, of course, a very broad one, and there are very obvious answers. We do that. We want to understand the world. We have a passion for knowledge, and above all, I think we marvel about the fact that the world can be understood by rational thinking and by observation. And this is what brought me to science, even if I did not know about it at that time. When I was in high school, it was the time when the race to the moon was starting. So rockets were being launched, satellites were starting to go around the Earth, and I was really marveling the fact that with the small amount of mathematics that I knew at that time, I was able to calculate the velocity of satellites or the velocity which was required to go. And this was my starting experience with science, and I have been marveling since then about the fact that physics can be understood through mathematical laws. I think our generation, the generation of all the scientists who are here to talk to you, is leaving to you a very paradoxical world. We have many reasons to marvel. The fact that mankind has a mind which allows it to start addressing questions which have been raised from the beginning of civilization. Questions like, what is the origin of the universe? What is the universe made of? What is life? Is there life on planets orbiting other stars? How does our brain work? And we start to have partial answers to all these questions. But there is still a lot of unanswered questions, and there is a fantastic ground, a fantastic field opening to scientists who want to start doing research today. And the byproduct of all this is also amazing. From basic science, we have been able to develop devices which have increased our power over the world. And most of the devices which are in our common life today, like the laser, the GPS, the computer, the cell phone, were quite unimaginable only 1 or 2 generations ago. And there are many other devices which will come in the near future, even if we cannot predict now what they will be. So this is a positive aspect of science. But there are some worries and some negative aspects too. One must say that the knowledge that we have acquired, that mankind has acquired, has not been accompanied by the wisdom that one could have expected coming from it. And we live in a very uncertain world because the power that science has given us, and there is a lot of power. I mentioned all these instruments that we are using in our everyday life, but we have to understand that the progress of science has allowed us to live more and more numerous on this planet. Think about the progresses of medicine, which have increased life expectancy, and the progresses of agronomy, which have allowed us to feed a population which is now 7 times as numerous ago. So this is positive, but we do that at the expense of exhausting the resources of the planet very, very fast too. And so science is giving us tools, but we don't take into account the consequences of what we are doing. And if we don't correct what we are doing now, of course we are going to a very dark future. It's clear that we have to take the steps which will allow us to moderate the climate change, to find new ways to use energy in a cleaner way that we are doing today, to find new medicines and drugs to avoid epidemics, and all this will require a lot of research. And so scientists today have to understand that science is not only useful to satisfy our innate curiosity, but it will also be very necessary to meet the challenges that I have just addressed. I want to also to add that there is another very important reason why science is important today. Science, as has been said already, is about truth. Science is based on the observation of facts and on the development of theories which are proven because they explain the facts and they predict new facts which will be observed. And so it's very important to reflect about this profound value about science. And the truth, as you know, is now under attack in society. We talk about a post-truth era. We talk about fake news. We talk about alternative facts, as if facts could be alternative. And this is propagated in the media. It is propagated also by communities of web users, which inside their own bubble are developing these plot theories. You heard about the fact that the global warming is a plot by the Chinese to ruin the Western economy, or about the fact that GMOs or vaccines are in fact poisons, and there is some kind of plot from I don't know whom to poison us with these things. And this is very serious because it takes over, and it is also propagated by politicians, sometimes at the highest level. I will give you a very sad example. The President of the United States has said that federal agencies should stop monitoring the temperature of the Earth just because he doesn't want to know about the warming. Or he also forbade federal agencies in their reports to use the sentence, "It is scientifically proven that." So this is exactly against the value of science. And scientists should know that, and they should know that, in fact, by defending the values of truth, which are the value of civilization, they are also playing a very important role. Because these values are not only important in science, they are important in the society at large, because they should allow educated citizens to be able, using these profound values of truth, to make the difference between the speeches of a statesman and the one of a populist. So this is a very important fact. By doing science, we are defending the values of civilization, which are universal values. These are not the values of one community over another one, of Western countries over developing countries, over the present time compared to past epochs. In fact, we are all part of the same civilization. And when Daniel Sachsman told this story about this scientist who was asked, will this be useful to defend the United States? I think what he answered, he said, no, it will not be useful to defend it, but it will make it worth defending. And I think that's the value of science, to make civilization worth defending. So there are reasons to be optimistic. After all, Galileo has won over the Pope and the Inquisition. Darwin has won over Stalin and Lysenko. And Einstein has won over Hitler and the Nazism. And these were much darker times at the time we are living today. So I'm sure that science will overcome the turbulence that we are living today, but we have to be careful. And if you become scientists, you will have to propagate always the idea that truth is superior to lies. The fact you will have also to try to explain what you are doing, to explain your research to the layman and to the general public, because after all, it is paid by taxpayers. And you have to try to express your enthusiasm and the fact that you are sure that the values of science and civilization will prevail. So if we can talk about a vocation or a calling, this is certainly a very important part of the calling, of your calling in the future. Thank you.
Merci, Serge. So now we have some word from Michael Levitt, Nobel Prize in Chemistry in 2013.
Bonjour, mesdames et messieurs. It's really exciting to be here because of the young people. And it leads me to a remarkable that is not so surprising, but often people forget that. And all that matters for us as older people is to worry about young people. I was very, very lucky. I started doing independent research when I was 20 years old. 51 years ago, it happened by accident, and you will discover that in life, often the best things are unexpected. They happen by accident. So I think the secret to life is to enjoy what you're doing at any given time. Never do something for something that may happen, because maybe it won't happen. Never plan that you would like to, I don't know, have a certain car in a certain time, because maybe you'll get a much better car in a different time. Life is very unexpected. I think life is intrinsically unpredictable and chaotic, but it's full of amazing surprises. So about my history, I started doing science 51 years ago, and between the ages of 20 and 25, I did all the work that essentially got me to go to Sweden. I could have stopped, but of course I was a scientist and I loved doing what I was doing. So the work that I was doing, it's going to be hard to do this with one hand, protein molecules are like strings. So my tie is like a string, but not being like this, they actually fold up into very precise shapes, like that. And this shape now does something in our body. And we have thousands of shapes like this, and all of life depends on these shapes that are doing things. Professor CIECHANOVER and Professor YONATH are studying these shapes, as am I. And the work that I did in the late 60s was to use computers to find a way to do calculations on these shapes. Nowadays, computers do everything for us. But in those days, computers were very large and very expensive. And I have to acknowledge the Weizmann Institute in Israel that in those days had the 15th biggest computer in the world, was some enormous computer. It cost $50 million in today's money. And as a student there, as a pre-PhD student, I was given unlimited access to these resources. So I think one of the secrets of promoting science is for young people to feel confident in themselves, to be given all the opportunities possible. And I would say that every senior scientist has one job, and that's to worry about young people. I would also say that many of the things that I would like to have said have been said already. I do want to say that in regard to the previous speaker, you know, the world may seem like it's not in a good place. But if you take a more global view and step back 200 years, we have never been better off. We have never had less war, less terrorism, less hunger, less poverty, less cruelty than we have right now. And it's important to remember that. People love to think about the bad things. There's a good psychological reason for this, but it's something we need to understand is not really true. So I think for the young people, you are in a terrific time. It's almost 80 years since the terrible period of the Second World War. When I grew up, there was a chance of an imminent nuclear war that was for real at any time. So this is a great time. Believe in yourself, do what you want to do, and go out and change the future. Thank you.
Alors, pour terminer cette première partie, avant la question, nous avons Yves MEYER qui a eu le prix Abel. Le prix Abel est un prix récent pour les mathématiciens. En fait, non pas comme la médaille Fields qui représente quelque chose pour les mathématiciens de moins de 40 ans, mais là, c'est pour récompenser toute une carrière. Et Yves a travaillé sur les ondelettes, et je dirais pour le qualifier que c'est le Fourier de notre époque.
Comment on fait défiler le... oui, bien sûr. Voilà. Donc, okay, so the title of my talk is À la recherche du temps perdu. So I was living in Tunis, and in April 1956, so 62 years ago, Jean-Pierre Kahn gave a lecture at the Institut des Hautes Études de Tunis. There was no university there. There was just a vague building where lectures were given. A talk at Institut des Hautes Études was truly a cultural happening there, and Tunis intelligentsia was not scared to attend a mathematical lecture. So I went there, and I was 16, but I still vividly remember Kahn's talk on Fourier series. Kahn was eager to disseminate mathematics following the beautiful tradition of the Age of Enlightenment. Kahn disseminated his knowledge, hoping that a disciple would show up. I happened to be this disciple. In 1963, I applied for an instructor position at the University of Strasbourg. After reading trigonometric series by Anthony Zygmunt, I decided by myself what shall be my research program. I was inspired by this book. At that time, I did not know that Anthony Zygmunt was a close friend of Jean-Pierre Cahn. In 1967, 11 years after listening to the talk by Jean-Pierre Cahn in Tunis, I became his colleague at Orsay. In 1981, after several unsuccessful attacks, I could solve Calderon's conjecture, but I was not fully understanding what mathematics are. Working on signal and image processing, I understood mathematics at a deeper level. I learned that the primary visual cortex is using algorithms which are sharing many similarities with the tools I was elaborating. So that alludes to the work by David Huber and Thorsten Wiesel on the functioning of the primary visual cortex. So I am ending this lecture by a discussion with Jean-Pierre Cahn. Thank you very much.